In part 4 of section 13, we're going to be looking at something called synthetic division with polynomials. Now, long division, I suspect gets its name because it is, well, it's long. And synthetic division is going to be something that we're going to learn that is going to simulate long division. But what's interesting is that you're never going to actually have to do any division to simulate long division using this synthetic division process. It's a really neat process, but it has to be followed to the T. There's a very specific way that it needs to be done. Now, synthetic division will replace long division, but not completely. It will only replace long division if, there's a big if here, the divisor is of the form x minus c, where c represents a real number. So anytime you have a divisor that's a very nice, simple x minus c type divisor, then you are permitted to be able to use synthetic division. So I want us to look at example 13.7, part A. It says, divide each statement using synthetic division. So we have here x squared plus 8x plus 15 being divided by x plus 5. This should look familiar. We did this exact same example in example 13.6 part A, but we did so using long division. So I've picked this problem again on purpose so we can see the connection between the answer in the from long division for what we're going to get for the answer in the synthetic division. So what we ended up getting here, and you're more than welcome to go back and look at it, is the quotient x plus 3 plus the remainder over the divisor. And since the remainder was 0, we just said that's going to end up representing 0. It's just going to go away. So the answer to this was just x plus 3. And that was the answer to the division problem for this. So we already know what the answer is supposed to be. The purpose of the example is for us to see this alternative way to simulate long division. Since we already know what the divisor and the dividend are, let's go ahead and create the separator that we're going to need for this process. The separator is going to look different than what we used in long division. I always envision this as being a 4, or at least this particular way of writing a 4. And then I put a tail on the 4. And that is going to represent the separator that we're going to use for synthetic division. In long division, you use that kind of separator. Here we're going to use this. So for this simulation, for synthetic division, we're going to take the dividend, and we are going to only take the coefficients from the dividend. That would be 1, 8, and 15. We put some space between them. They're expected to have a little space there because they're each going to represent their own column in this process. Next, we want to look at the divisor. So the divisor, I'm going to do a little separate analysis over here of the divisor. The divisor in this case is x plus 5. Now, we were told that the divisor is supposed to be of the form x minus c in order for this to work. And certainly x plus 5 is not the same as x minus 5, for example. So it doesn't seem to have the same form that we need to do synthetic division. Does that mean that all hope is lost? No, it's not. I can always take this divisor and I can think of it as x minus negative 5. That's 100% equivalent to x plus 5. That is saying the exact same thing. And so now I can identify negative 5 as being a real number, and that is going to be the real number that we're going to use to represent our divisor. So we're going to take negative 5 and we're going to put it in this part of our separator. This almost completes the setup. There's one final thing left to do. So there's a little bit more on the setup than there is with the long division. We're going to bring down that first coefficient below the tail. Now we begin our process. So our process is going to take the divisor value and we are going to perform a multiplication. We are going to multiply with 1. Negative 5 times 1 is negative 5. We will take negative 5 and we will put it in the column next to it. As soon as you get a column filled in, you will then need to add those values together. 8 plus negative 5 is going to be positive 3. That's one round of synthetic division. Let's do it again. So the rounds go a little bit faster, but the setup takes a smidge longer. Now let's do multiplication again. So this time we're going to take negative 5 and we're going to multiply it with 3. So that's going to result in negative 15. That's a column that's complete. Let's add that together going down, and we're going to end up with 0. So the answer to this problem we know is x plus 3. And we also know that the x plus 3 is the quotient and that the remainder was 0. And that's why we don't see the remainder actually appear in the answer. So rather than having your quotient and your remainder at the top and the bottom of your process, they are all grouped together down here at the bottom. Here is your answer. It's all right there. The very last number that you write represents the remainder. Next to that is your constant term. Next to that is going to be the coefficient for your x term. So what this means is that the bottom line is split into the quotient and the remainder, where the remainder is just that first part, and then everything to the left of that is going to end up representing your quotient. So you can see where we have 1x plus a constant of 3, and that results in x plus 3, with the remainder, of course, being 0. This is called synthetic division.